Put your hand flat on the nearest surface. Press down. You can feel it. Solid, cool, undeniably there. Except you are not touching it. You have never touched it or anything else in your entire life. Not this table, not your phone, not another human being. Every handshake, every kiss, every time you thought you made contact with the world, you were hovering a hair's breadth away, and something invisible was holding you off. This isn't a word game. It's a straight consequence of what atoms are and how they behave. And the thing keeping you from ever touching anything is also the thing that makes the world feel solid at all. Let's go down to where your finger meets the table. Everything is made of atoms, and every atom is wrapped in a cloud of electrons. Electrons carry negative electric charge, and here is a rule you already know in your bones. Like charges repel. Push two negatives together and they shove back, harder and harder the closer they get. So as your fingertip descends toward the table, the electron clouds of your skin approach the electron clouds of the surface. Negative meeting negative. Long before they can ever touch, the repulsion between them ramps up into a wall of force. Your finger stops, not because it hit anything solid, but because the electric fields pushed back hard enough to halt it across a tiny but real gap. What you're feeling in that moment is not the table, it's the repulsion. You are feeling a force field and calling it a surface, which raises a strange question. If you never make contact, why does touch feel so utterly convincing? Because touch was never contact in the first place. Buried in your skin are millions of tiny sensors, mechanoreceptors, that respond to pressure and deformation. When the repulsive force pushes back on your fingertip, it squashes those sensors slightly, and they fire electrical signals up your nerves to your brain. Your brain takes that stream of signals and builds a sensation: solid, smooth, cold, there. Every texture you have ever felt, silk, sandpaper, a loved one's hand, is your brain's interpretation of electromagnetic pushback translated into feeling. You have never once felt an object. You've felt the force an object exerts and the story your brain wrote about it. The world you touch is a rendering, but electric repulsion is only the first line of defense. There's a second wall behind it, and it's stranger. It's the real reason you can't melt through your chair. Suppose you could push hard enough to overcome the electric repulsion and force the electron clouds to actually overlap. You still couldn't. A far deeper law slams the door: the Pauli exclusion principle. Electrons are antisocial in a very precise way. No two electrons can ever occupy the exact same quantum state, the same place, doing the same thing. It's forbidden, absolutely, by the rules of quantum mechanics. So when you try to squeeze the electrons of your hand into the same space as the electrons of the table, they would have to start sharing states. They can't. And to avoid it, they push back with a ferocious energy that has nothing to do with electric charge. It comes purely from that rule of exclusion. This is the force that actually holds up the solid world. It's why the floor carries your weight, why the wall stops your fist, why you don't sink through the mattress into the earth. It isn't stuff blocking stuff. It's a quantum law forbidding electrons from sharing a seat. A rule so strict that entire dead stars, white dwarfs, are held up against their own crushing gravity by nothing more than electrons refusing to double up. Here's the final twist, and it makes the whole thing worse. That solid table your hand is resting on, it's almost entirely empty space. Shrink an atom's nucleus to the size of a marble, and the electron cloud around it would spread out to the size of a sports stadium, with nothing in between. Matter is something like a trillionth actual stuff. If you removed all the empty space from every atom in every human on Earth, the entire species would compress down to roughly the volume of a sugar cube. So the object under your palm is a near-perfect vacuum, laced with a few specks of matter, held rigid by force fields and a quantum prohibition. And it stops your hand cold. Both things are true at once, almost entirely empty and utterly, reliably solid. Solidity was never about being full. It was always about force. So, you have never touched anything. Every point of contact in your life has been a near miss. A fingertip held a fraction of a nanometer off a surface by the repulsion of electrons, which never quite meet, and which by the deepest law of quantum mechanics are forbidden from ever truly meeting. The solidity you trust so completely is not stuff pressing on stuff. It is force and rule and empty space, arranged so precisely that it feels like a wall. The good news is that none of it matters for the hug. The force is real, the resistance is real, the warmth conducts across the gap just fine. You can spend your whole life never touching another person and still hold them. But the next time your hand rests on someone else's, know what's actually happening. Two clouds of charge, hovering, never quite in contact, as close as the universe will ever let anything get. That's the fine print on the most ordinary thing in the world. And it's stranger than the world lets on. Which is exactly the point of this channel.